What we'd like to do is we'd like to review for the practice quiz and discuss the different ideas that we're going to talk about here. Our first equation is 1/2 x minus 3. We start by plotting the point -3 on the y-intercept. We then go up 1, and over 2 a number of times on the graph, and then in the opposite direction, down 1 and back 2 in the other direction. Once we graph points all the way across the graph, we take our straight edge, make sure we draw our line between all the points on the graph. Put arrows on the end of the graph, remembering that there's more off the graph than on the graph. We're then going to graph our other line, -3/4 x plus 2. Our slope on this is -3/4, and I just want to remind you that the negative is going to go on the top. We start at the point 2 on the y-intercept, and we go down 3 and over 4. Down 3 over 4. We're off the graph at this point, so let's do it backwards, up 3 and back 4. We now have our two lines. We can draw our second line in red. Now remember, the solution is not the graph. The solution is where the points cross. And in this case, the solution is the point 4, -1. Now we look at our next problem. I want to talk in our next problem really about the general ideas of what we're dealing with here in terms of comparing two lines on a graph. We have three possible scenarios as a solution. The first scenario is that the graphs cross once. The second scenario is the graphs cross no times. And the third scenario is the graphs cross an infinite number of times. When will they cross once? They will cross once if the slopes are different. When will they cross none at all? They'll cross none at all when we have the same slope, but we have different y-intercepts. And they'll cross an infinite number of times when the equations are the same equation, causing them to have the same slope and the same y-intercept. So in this case, we compare our points. We have 3/4 and 2 as our slopes. So it seems like the slopes are different. That means this scenario, the graphs will cross one time and have one solution. Our third and bottom problem on this page is solving by substitution. As we solve by substitution here, we're going to take the value of x equals 3y minus 5, and we're going to plug that in for the value of x in the top equation. That gives us 3y minus 5 plus 4y equals 23. We now combine the y's on the problem, giving us 7y minus 5 equals 23. We add 5 to both sides, giving us 7y equals 28. To solve this problem, we divide both sides by 7, giving us an answer of y equals 4. This is half of the problem. We're now going to have to try to solve for x. I'm going to use equation 1. X equals 3y minus 5. And we're going to plug in our value of y. 3 times 4 minus 5. That's 12 minus 5, so x equals 7. I need to check this by plugging into the second equation. Our second equation that we're going to use in this case is the top one. X plus 4y equals 23. I plug in my value of x, which is 7. I plug in my value of y, which is 4. 4 times 4 obviously is 16. And it is a true statement. 23 equals 23. So we have success on this. This ends part 1 of our practice quiz.